Hello everyone, I am Chiranjeevi and you are watching episode 5 of Rush series. In this episode, we are going to discuss about variables, constants and their mutability. If you think, haha, variables and constants, I know already, I know many programming languages, then you are probably mistaken just like me. Because Rust has a very strict policy of how you use these variables and constants and when you use them especially. So let's see how we do that in this video. Now let's see what these variables and constants are. This is nothing specific to Rust and this is common in every programming language. We will see how this is little bit different in Rust later in this video. So let's see what a variable and constant is. We have discussed about data and data types in our previous episodes. If you haven't checked them, please do check them out. And here let's see what we are going to do with variables and constants. So you have stored some data in your memory for some computational purpose. Let's say you have stored some number 22 and some name Chiru. So let's say you took these values as input from user or you have created them in your program itself. So you want to use these values again in your program somewhere else. How do you do that? You will have to have some reference to these variables which will allow you to call these values somewhere else in your program. So these references to values in memory. How do you have these references to these values in your memory so that you can call them in your program somewhere else? This is where variables and constants come into the picture. So basically a variable or a constant gives you an identifier which will identify these references and give you those values. So basically both variables and constants are just identifiers which identify the values in memory. So what is the difference between variable and constant then? Both are identifiers, but what is the difference? So basically if an identifier, if it is a variable, it can change its value. Let's say if uh, x is a variable name, it's an identifier. If it is pointing to 22 at some point of program, it can change its reference. Now it's no more pointing to this, and you can say it will point to this now. You can do that because it's a variable, its reference can vary. That's the basic meaning for the name variable. So its reference can vary. You can say that this x no more points to this 22 and this will point to this thing. You can do that. But if it is a constant, if it is a constant, it can't change. If you reference a constant, let's say const1 is this name. If you say this const1 is referencing to this string and you can't tell that anymore referencing to this string and it's now referencing to this 22, you can't do that in your program. That's the major difference between variable and constant. In other words, this is mutable, a variable is mutable, a variable's reference is mutable and a constant's reference is immutable. This is a major difference between a variable and a constant in general programming terms. This is not specific to Rust. This is common to any programming language you choose. Let's see how it is different in Rust. In Rust, both variables and constants are immutable. What? Including variables? Yes, both variables and constants are immutable. Then what's the point of having both? If variables are immutable, they are obviously constants. Exactly. But the point here is that we can make these variables mutable also by using, we can make variables mutable using a keyword mute. So by default, variables are immutable in Rust, but you can also make them mutable with this keyword mute. So how is this going to help us? Let's say you're writing big programs, big projects in Rust. So in those programs, you will create a lot of variables and you will change them sometimes and you won't change them sometimes. But if you want to specify if you are going to change that variable or not later in the program, then you can use this mutable keyword. if let's say if you're going to change that variable somewhere in the program later, you will specify mute. If not, you won't specify the mute. So let's say if you're not changing the value, then if you know you're not changing the value, you can use constant, right? Why use variable there? That's a valid question, and let's see why it's not the case in Rust. In most programming languages, when we are trying to store some data which is coming from user or from some API response, which is not going to change in the program anywhere else, we use constants there. In other languages where data won't change once given, we use constants. This includes any user input or any API response which is not going to change somewhere else in the program. But in Rust we can't do that. Even though the value won't change after that, we can't do that because the value must be known at runtime, at compile time, sorry, not runtime, must be known at compile time. So when the Rust program is compiling, the Rust compiler should know what value is going to be stored in that constant. When it's a case of user input or from API response, we can't know what's the value until the program is run. So the value is known at the runtime in case of some user input or from some API response or from some server response. But we have to know the value at compile time. So this is where this mute keyword actually helps. Let me give you a flowchart which will tell you when to use a immutable variable and when to use a mutable variable and a constant. So if value changes, if the value changes in the program after creation of that variable or constant, if yes, if the value changes, then we have only one option, which is mutable variable, because this only supports the changing of value. If value is not changed, then we have to ask another question, which is if value is known at compile time. If the value is known at compile time, if yes, then we can use a constant. If the value is known at compile time but still the value won't change in the program, then we have to use immutable variable. So this flowchart helps you deciding on what to use and when to use what. Now let's see the syntax of creating each of these. So how do you create a variable? We have to use a keyword. A keyword is nothing but which has a specific meaning in the programming language. In Rust, there is a keyword called let, and space will give the name of that variable and type. This is colon, after colon we give type, and this is optional in variables. After that I will give this value. Since this is a variable, this value can come at runtime like a user input or a API response. This is for immutable variable. So this value should not change anywhere in the program after creation of this. So now let's see mutable variable. Let space mute, which is another keyword, space name of the variable, and type. This is also optional. So type annotation is optional in variables, and the value. This value also can be come from runtime, any user input or a response. This is mutable variable. Now when it comes to constant, the keyword is different, which is const space name. The convention to name a constant is name should be in caps, all letters should be in caps, and type. This type is required. This is not optional. We have to compulsory specify the type of the constant and the value, and this value should be known at compile time, which is very required for a constant. This is a constant. So these are the syntaxes that we use to create a immutable variable, a mutable variable, and a constant. Now let's implement what we have seen just now using code. So I'm inside this projects folder which I have created in one of the previous episodes. Now I'm creating a new project. How do I do that? Using this command called cargo new. If you don't know about cargo, check out the episode 2 of this Rust series where I have discussed everything about cargo. So cargo space new space name of the project. Since this is about variables, I am calling this as variables. Now if I click enter, this created a new project which is variables. Now if I go inside, it will give me some default files. In that what I need is this main.rs file. So I'm removing this hello world line which came by default. Now what I want to do is I want to create a immutable variable. So how do I do that? The syntax is let space name of the variable. I'm calling it as immute var, and let's give it some value which is 10. Any value is fine, and we have to end every line with semicolon. Now we want to print this variable. For that we need to use a function println, and in println whatever it prints should be given inside double quotes. So if it is something which is a string, which is a text, we can give something like this, the text or something. But what to print is 10, which is stored in the variable immute var. So for that what we have to do is we have to use something called placeholder. So what this will do is this closed curly brace and open curly brace and closed curly brace, this will tell that it will take a variable and print the value inside that variable. So after double quotes we have to give a comma, and after that we have to specify the name of that variable which we want to substitute in the place of this placeholder. So if you have multiple variables and you want to print them all in the same line, what you can do is you can add another placeholder, and after this comma you can add another variable. Since we have only one variable, we don't want to do that right now. So this is how we can print this. So now let's save this. So before running anything, make sure you are inside the variables project, which I am not there. So I have to go inside variables project. Now we have to run this project. How do we run the project? Using the command. We can either build this and then run this, which is a very slow process, or we can use something called cargo space run. This will run the project after compiling it automatically. So if we run cargo run, see, it compiled, finished, and then ran, and it printed 10, which is the value stored in immute var. So we know that this is an immutable var because we haven't specified mute keyword here. Let's try changing the value and see how it's going to reflect in the output. So let's say immute var is, let's change the value to 20. So what it should do is it should throw an error because this is an immutable variable. We can't change this value after creating. So let's try running this. Let's use the same command again, cargo run, and now press enter. See the output. It's saying cannot assign twice to immutable variable. Since this is an immutable variable, we can't change the value, and it's showing something help. Consider making this binding mutable, mute this thing. So it's also suggesting us to use mute keyword to make this mutable, and so that we can change the value to this. So let's try doing that. Let's see what we can do. So let's create a mutable variable, and let's change the name as well to mute var. So now let's try compiling this. I am expecting an error here. Let's see why. Cargo run. See this. So it finished compiling and it ran and it gave output 10, which is expected, but it's throwing an warning. See what this warning is. Remove this mute. It's helping us via telling that remove this mute keyword because we are not changing this value anywhere. Since we are not changing this value anywhere, we can use an immutable variable. So that's what it's throwing warning for. Now let's try changing this value mute var to 20. Now this warning should go and the value should also be changed. Let's see. I forgot a semicolon. Try to read the errors and change your code accordingly. So we got another warning. Let's see what it is. So it is saying value assigned to mute var is never read. So we have assigned value 10 here, but we never printed it or we never used it anywhere. Before doing anything, we already changed the value. That's what it's saying. You have assigned this value to the variable, but you haven't used it anywhere, and you reassigned it to some other value. That's what it's saying. So that warning is fine. Even if you want to remove that warning, what you can do is you can copy this line, this print line, and paste it here. So what we are doing here is we are printing 10 first and then changing the value, and we are printing 20 again. Now let's see that we got 10 and 20 as outputs. So this is about mutable variables. Now let's see about constants. So how do we create constants? Using const keyword. So according to the convention, we should give all caps. So let's call it as test equal to, give it some value, 20. Now let's try to print this. Println test. So remember that I told you that we have to specify the type compulsory. Now let's try running this without type annotation and see what error it throws. So it's showing that provide a type for the constant. So since we are using an integer, we can use unsigned dot signed because we are not specifying any negative integer here. So let's say it's recommending i32, so let's give i32 itself. Now let's try to run this again. We got our output. Let's try to change this variable after creating, so that it will throw an error, and let's see that error. Test equal to some 30. Save it and run cargo run. Oh, showing me to put a semicolon. Cannot assign to this expression. So could not compile variables due to previous error. So it's saying that we can't reassign a constant. So this is one thing. Another thing we discussed is we can't get the value for a constant from runtime, or if the constant doesn't know the value at compile time, it will throw an error. Let's simulate that. We haven't seen how to take a user input yet, so let's simulate how we can do that. We will learn about taking user input in one of the future videos. So for that, what we are going to do is we are going to create a variable. Let var equal to, let's say, some 10. And what we are doing is we are giving this test a value which is 20 plus this var. So it's basically adding 20 plus 10 and assigning it to the test. So now it should print this test. This is going to give us error because the compiler can't do this at compile time. Let's try running this. See what it's saying. Attempt to use a non-constant value in a constant. So this is a non-constant value and you are using it in constant. So whenever you are using non-constant values in a constant, it will throw this error. This is same to if you are using user input or some API response in const. Generally, JavaScript developers who work with APIs know this, that we take any API response as a constant. So this is not possible in case of Rust. So this is the demonstration of how we can use mutable variable and immutable variable and a constant. That's pretty much it for this video, and please like and share if you felt this video is helpful and you have learned something from this video, and do let me know in the comment section how you felt about this video, and please subscribe for the future episodes of Rush series. Signing off.